Good morning, good afternoon, or good evening, wherever you are on this lovely planet Earth. We have a very exciting Thursday planned for you where we have Owens Corning and in kind of recognition of International Women's Week, we're going to have Tiffany Coppock play the role as presenter. But yeah, we were going to bring in the Pink Panther, but not as entertaining as Tiffany. So we're really excited to have Tiffany on board. As she is the commercial building system specialist at Owens Corning, where she provides leadership in building science, system development, testing, and documentation. As new systems transition into use and for existing systems and products, she provides technical guidance, integrating the entire building envelope for design professionals, as well as the Owens Corning team. While at ease in her air-conditioned comfort of the office, she owns several pairs of muddy boots and is no stranger hands-on application and detailing of multiple building products. Tiffany, I'm going to turn over the controls to you, and we are going to learn about insulation solutions for passive house projects. The floor is yours.
Thank you so much, Sean, and thank you everyone for having us. I do want to start out with just a little bit of an apology. I know my audio is not going to be as great as I would like for it to be. I am recovering from COVID, but thank you so much for bearing with us today and for having us. So speaking a little bit about Owens Corning, we had this opportunity to either talk about a passive house project or talk about our materials, and we chose just to initially really present to you a lot of the materials that we have as solutions, because so often, like Sean said, we think about the Pink Panther, maybe we think about we have some pink stuff. Do you want to buy some fluffy pink insulation? But there is just so much more in our kit parts in our portfolio. And so we thought this would be a really great opportunity just to share and start the conversation. Without further ado, I actually want to take a very rare opportunity. Usually I'm jumping in immediately to technical answers and questions. But to really jump in and talk about Owens Corning as a company. I'm just so proud to be a part of this team and to talk about our sustainability pathway. This is a journey for us. This is not a single box that we check or a single goal that we reach and we feel like we've accomplished what we need to accomplish. We are ever striving to do better. So you can see here, years ago, when I first joined OC, we were talking about our handprint and our footprint. So not only the impact that we were having on the world with the materials that we were making, but also with the manufacturing process itself. How could we make improvements there? And you can see here, we're also starting to, and have in the past decades, talked about our people and our environment and our community. So we're really proud to stay involved in our community, do a lot of outreach and giving back. That is at the core of our company. We take holidays throughout the year specifically to be able to give back to our community. And I know you guys have probably seen some of the really cool projects that we have volunteered materials and expertise and labor on. So we just want to continue doing that. And then you'll see here, we're really starting to work in the inclusion and diversity space. We actually have an entire department dedicated to creating a better community culture within our own company, as well as sharing the information that we've learned outside of the company. So I'm actually here in Dallas today, where we just recently had a National Women in Roofing event. And we have consistently participated in that and helped share some of our insights to help others with inclusion and diversity. We have not solved all the problems yet, but we are definitely part of the conversation. We want to remain so. And then at the end of this stack of kind of our vision of sustainability, you can see that we have worked towards our impact on the environment. So it's no longer just a conversation of recycled content, but the embodied carbon, the life cycle that goes into all of these materials. So all of that really adds up to, we really value not just our products, but our people, and we want to make the world a better place. So that is our aspiration. This is our aspirational goal as a company, both in manufacturing at the corporate level, at the science and technology level. This is really something that you'll see us repeating to each other and to ourselves in everything that we do. And as a result of that, you'll see a lot of the certifications and things that we work towards. So you're going to see some of these today, and feel free to ask questions about specific ones if that's something that you're interested in. This will vary, of course, by product and application and where the product is made, but it's something that, of course, we're always striving towards. As well as speaking to that IAD, we want to make our company a good place to work. So this is something that we don't want to be boastful about, but we are, proud to be a good place to work with. So all of that said, back to the technical, the stuff that we get to work on every day. We tried to break down our insulation products into some categories for you. And admittedly, a lot of the products that we make would be for continuous insulation, but we kind of started with kind of the big ones that you would know of. And the first one is our thermofiber rain barrier mineral wool material. This product is for specifically exterior application. It is moisture resistant. It actually repels water versus absorbing. I know that there is a horticultural product that we also have available for the purpose of absorbing moisture. We could actually engineer that product to do something different. It has a very high R value, up to 4.3 per inch thickness with this particular material, and it is non-combustible. So in the US, flame spread and smoke development, ASTM E84 00, Canada 05. And what that really means is when we start to talk about applications like NFPA 285, for instance, you're doing a high density residential facility, apartment building, something like that. You may be in a situation where just having a material that's non-combustible, like this material, we were not triggering NFPA 285 if there are no other non-combustible materials in the assembly. So we're really proud of this product. It is very flexible with regard to just how it could be used in the assembly. If you need to build a vapor permeable wall assembly, you can do that with this material because it is highly vapor permeable. If you want to build a vapor impermeable system, you can put that vapor barrier on the outside or the inside. This mineral wool isn't going to negatively affect that. So I know as we really get into fine tuning and engineering the buildings with Passive House, this is a real solution to those problems. And additionally, I would also say that this product has great acoustic performance properties. So when we're looking at living spaces that we want to make more comfortable for the occupants, being able to reduce that noise transmission from the outside in is really important. And this is one of those materials to be able to do that. For attachment, this material can be attached with impaling pins, screws and washers, girt systems. There are a lot of different solutions here. So we can definitely help with all of those different options. The next one is our Foamular and Foamular NGX extruded polystyrene insulation material. This one has an R value of 5 per inch thickness, and it is moisture resistant. It's also hydrophobic, so it again repels water. It comes in a 4 by 8 foot sheet in most scenarios, up to a 4 inch thickness. And it will be used for controlling vapor as well. So a little bit different from your mineral wool as far as approaches, but we would make sure that we would design that correctly from the beginning. One thing I want to point out with this particular product is the NGX, the next generation extruded. This was the first to market to be able to meet some of the newer ordinances and requirements, both in Canada and the US, to reduce or eliminate HFC 134A, which is a glowing agent that we want to eliminate from product to prevent global warming potential. So that reduced that global warming potential down to 80, which is something that we're really proud of. And of course, we're always striving to do better and better. Things to consider with this particular material, how you would attach it. You could use an adhesive Could use a mechanical fastener, such as a screw with a washer, or it can be compression fit between masonry wire tie eyes, just like the mineral wool as well. We would also want to make sure that we've included this product correctly in the correct fire design applications. All right, so now we'll jump into some cavity insulation. And this is probably the tried and true that we're all familiar with, the pink fluffy stuff. So this is our fiberglass insulation. It varies with our value, but I would say that we're going to be looking at this material based on your cavity depth and space, and we can actually get a little bit of variation out of that with density. So we would be more than happy to answer more questions related to that. Usually this material is one of the most user-friendly products that gets installed because of its ready availability, its fire resistance. It does have a very high recycled content, up to 60, or average 60%. And it does provide good acoustic properties as well. So again, for those passive house homes, we want to make sure that we have good properties for our occupants. This is a really great solution as well. I will also point out the next gen, not to be confused with the NGX, but the next gen is related to some new versions of this material, which provide for better recovery as you take it out of the package, and being able to have it stand up and fill that cavity space much more easily. It's just better, easy handling. And I also want to note, this is kind of old news to those of you who have worked with the product in the past decade, but it no longer itches. We took that itch out of the material many years ago. It has to do with the way that that product was engineered, and we re-engineered that, and of course removed the formaldehyde in the binder years ago. So if you still have that preconceived notion, I challenge you to walk through a big box store and go handle the material and just enjoy it, try it out a little bit more. As far as attachment goes, this of course is compression fit between the cavity studs, either a steel stud or a wood stud. It comes in both options and dimensions, but we also may see it wire tied in. So those are our other solutions as well. Likewise, we also have this in a mineral wool version. So the thermal fiber Fire and Sound Guard Plus is also an option. And you can see there, he's just cutting that material to fit just like you would with the fiberglass material. Again, this material has non-combustible properties, really great acoustic performance, and we can provide quite a bit of really interesting research and studies based on the stud wall assembly, if you're interested, as well as we do have this material available in formaldehyde-free and red list-free. Same attachment options, whether it's compression fit or may end up using a wire tie in certain scenarios, but compression is the most common. And then I also want to point out, both for the fiberglass and for the thermofiber, we do have blown-in options as well. So where you may need those particular applications, such as an attic application, or in some of the stud spaces on historic buildings where we can't open up the entire wall, this would also be a really great solution. And then new to the scene, if you've been keeping up with Owens Corning, we've got a couple of newcomers. This is our natural polymers material. We acquired natural polymers 2 years ago. And this material has a high R value. We have this material in both a 1/2 pound and a 2 pound. And it's going to be able to control air movement. That's how we're getting our higher R value, as well as this one has a special feature of reducing odor. So it's still very new to us. We're still learning about it along with you, but we're really excited to add it to the portfolio and be able to create some additional application options. All right, so moving into other parts of the building. Again, this would be continuous insulation as well, if you want to think about it that way, but under slab applications. So this would go underneath either a structural slab or even a parking deck, a parking garage. These would all be really great options. And you'll see here, we've even got some radiant heat just on the walkway. So a lot of different solutions here with extruded polystyrene insulation. Again, the same R value that we would expect for the wall in R5 per inch. It still comes in that 4 by 8 foot sheet. And we do have a lot of details to help with either the reinforced concrete slab in a split slab scenario, or with under slab applications, and even the radiant heat, as you see here. Then we have a couple of problem solvers, which is a category we didn't really have a specific place for. So we addressed that with thermal bridging as the category. So this is also a newcomer. Owens Corning acquired Pittsburgh Corning cellular glass insulation manufacturing about 6 years ago. And you may recognize them in the pipe application industry, but this can also be used in a lot of really unique situations for the building. And namely, this is one of the targets that we've been working on for the past year, which is the foam glass parencyl SIB, which is a structural insulating block. This material is being used underneath the masonry veneer. It does require some engineering, so there's some rules of thumb. We do have a design guide to address that, but in general, we're saying with a masonry veneer, if it's only masonry veneer, up to about 20 feet above the parencyl would be a really great application. You might see that on schools and apartment buildings and things like that. This would be a really great application. And this is really just addressing that thermal bridge where you have below grade insulation and you have above grade continuous insulation, but we really didn't have a solution for that area where we needed to carry the load of the veneer, and yet we need to insulate because nothing was able to hold that much weight. This material, because it's cellular glass, has a very high compressive strength of over 240 psi. And so we're able to use that material for that application. More problem solvers here. You'll probably see these twice. This is the thermofiber mineral wool safing material. We use it all over the place. If you are familiar with NFPA 285 applications, I really like to use it around window openings, window heads, for preventing the fire from reaching into that cavity space. But again, this material also provides some acoustic property, which is a nice benefit when, especially in 285 window opening details. Your other options are things like a steel lintel, which would create a thermal bridge, or a wood buck, something like that. Mineral wool is a really great solution for that. So we're really glad to have that in the portfolio to solve a lot of problems. It also gets introduced into floor line applications, and we'll talk about that again in a little bit, as well as we can manufacture it in specific shapes and forms to fit at the tops of those flutes of your metal deck. So where you need to stop the passage of fire or just acoustics and thermally, this would be a really great solution as well. It's already pre-made for those dimensions and applications. Similarly, we may see some slab edge XPS or edge banding. Of course, we want to make sure that you address the fire requirements there. So if it does need to be protected with a 15-minute thermal barrier, those are all options. But this is also just a really easy product to cut and shape to the dimension that you need to address a lot of these little thermal bridges that pop up all over the building or the edge of the slab, like here in Texas. So I did allude a little bit to fire protection, and I'd be remiss if I didn't talk about what's basically an entire department here at Owens Corning, and that is our thermofiber perimeter fire containment assembly, which is known as impasse. And we have specific anchors and hangers all patented for these applications in fine tested assemblies. So you'll see our impasse hangers, you'll see the fire span insulation. In these situations, we're looking at spandrel glass and how much vision glass we can actually maintain. Look for some new announcements very soon related to that, something we're really proud about. But also for perimeter fire containment, anywhere where you have a fire-rated wall that intersects the exterior wall, a fire-rated floor that intersects an exterior wall, you should run into a situation where you need perimeter fire containment. So this is a really great solution for that. We have an entire department of engineers and the technical team specifically able to answer questions just related to these applications. And so you're looking at one solution, at one common solution, but there are a multitude out there for your particular project. And I talked about it earlier, but that same top stop material, that same saving material would of course provide the same fire protection as well. So a lot of good solutions here with regard to fire. Again, our newcomer, cellular glass insulation, so foam glass has a number of fire stopping listings as well for pipe penetration, a lot of different solutions for the annular space. It may not be something that you run into every day, but I did want to acknowledge it a little bit, especially if you're working on buildings that have a lot of penetrations through fire rated floors because you've got separation due to occupancy or something like that. This would be a good solution. And I would also be remiss if I didn't talk about air sealing. So I want to give a little bit of a shout out both directions. So we do have both extruded polystyrene insulation and spray polyurethane foam insulation listed as air barrier systems. But even if you're not going to use one of our products as an air barriers are very integral in the performance of insulation. We want to make sure that in reducing air movement, the concept of insulation is basically a trapped gas. So either that gas is atmospheric air, like the space I'm in, or it's a blowing agent, which gives you typically a higher R value. So anywhere we can keep that gas trapped, we're actually going to increase our thermal performance, our thermal resistance. So whether you use, I know Persoco is another company that provides air barrier materials and is the sponsor of Passive House, that would be another solution as well. But we just want to make sure that we've addressed the fact that air barriers are very important to the performance of systems, as well as vapor control. You can have both a vapor impermeable or a vapor impermeable system. And as you've seen earlier, we're able to address that both with mineral wool and with extruded polystyrene insulation and all the other insulations in between. But we just want to make sure that that is addressed and we don't trap vapor in the wrong location. Now we jump into a couple of unique construction solutions. So some fun areas that we get to play in, and we always like to highlight a little bit more. Precast is one of these. This is from a previous presentation, just really promoting the attributes of precast construction. So here is an example of a conventional masonry built building. Nothing wrong with that, fantastic performance. Compared to a sandwich wall system, which is insulation sandwiched between two layers of concrete. And as you know, with a school system, we're really limited in the construction timeline. We basically get that referendum to pay for it with tax dollars. We want to get that building built as quickly as possible. And you can see here, due to the location, we're also limited in construction time related to weather. So we want to construct as fast as possible. So in these example buildings, we saw that a precast wall system was able to be constructed in almost half the time period versus the conventional masonry. Nothing wrong with masonry, but just pointing that out. And versus either electrical or natural gas, both of the energy usages went down because essentially we've got less thermal bridging. We've got continuous insulation protected within the wall from the start because it was a sandwich wall system to begin with. So a lot of different options there. And we have a whole presentation just on precast if that's something that you're interested in, as well as a precast design guide. And that's one of our major, customers, if you will. We provide a lot of insulation to precasters around the country and across North America. Same thing with regard to other construction types. We are very active in rain screen panel applications. And so here we're showing a couple of different materials. We have one of our newest products out, which is the Thermofiber Rain Barrier Dark. It has a dark black facer, specifically for exposure when you have kind of those reveals between the different panels. This is going to be able to give you some more design creativity opportunity. So that material is available, as well as our Rain Barrier HC, which is a high compressive strength material. We are really proud that this material, we were able to increase compressive strength without necessarily directly increasing our density of the material. So a lot of the things that allows you to do is direct application of your cladding. We can really start to look at less thermal bridging with regard to fasteners and panel systems. So a lot of options there. And again, same great properties as our rain barrier line up to an ARC 4.3 per inch thickness, as well as the moisture resistance we all expect from that material. And then, as I mentioned earlier, I'm at the International Roofing Expo right now. We just had a great talk about commercial roofing applications and high performance roofs. Plaza decks are a big opportunity for us, and that's an area that we particularly specialize in. So both with our Foamular NGX and our Foamular XPS material, as well as our foam glass, cellular glass insulation, both of those materials do get used in these plaza deck applications regularly. And that's because of their high compressive strength, number one, but also because of their water resistance. Both of them are very water resistant. Even foam glass has been tested to be actually waterproof. So we subjected it to, it's not a code requirement or anything, but we subjected it to water column testing, just specifically to be able to know how much it's able to resist, which was over 37 feet of water pressure. So that's pretty impressive. And then foam glass itself, as you can imagine, because it is a cellular glass material, it's made of glass. It is also non-combustible. So depending on the application that you're looking at, we've got a solution for those plaza decks that you may be driving a truck on top of, building your vegetative roof on top of, any of those situations. And I also want to point out just some geometry that we are particularly adept at based on having a diverse portfolio at Owens Corning. So the photo on the left, I have to fully admit, is a project that I worked on prior to joining Owens Corning. But conceptually, the spherical shaped building has always been a challenge for a 4x8 sheet of rigid insulation board. And so in this particular situation, a spray polyurethane foam would be a really great option for a curved or irregular shaped building. So this is demonstrating that that might be a really great option. And by example, this is Nature Research Center in Raleigh, North Carolina. On the right-hand side, you'll see the Salesforce Tower, and I can't remember exactly which one the building is, but these are mineral wool solutions. Also able to put mineral wool in perimeter fire containment and as a continuous insulation with like a rain barrier in these scenarios where we have curved surfaces or irregular faces of buildings, and that material is particularly forgiving. So no matter what you can dream up, we can help you insulate it, I guess is really what we're taking home here. And finally, I just want to close by talking a little bit more about the resources that we have at Owens Corning. So one website that I would encourage everybody to visit is our Enclosure Solutions website, which is www.owenscorning.com/enclosure. From there, you'll be able to basically answer those questions that you see. What are you building? How are you building it? We have a solution. You can select a wall, a foundation, or a roof application, and then start sorting by what insulation you would like to use, what your substrate is, what your cladding is, what your overburden is. And we can help you narrow down what code requirements you may need to meet and provide all of that documentation specific to your particular application, including CAD details, guide specifications, data sheets, tech bulletins, all that good stuff. Likewise, I alluded to it earlier, but the InSolutions team, as we call them, has a specific resource for you, and that is the www.owenscorning.com/PFC for perimeter fire containment. This is where you would go when you're working on those curtain wall assemblies, where you're really needing to get an engineering judgment specific to an application that you're building. We have people on staff specifically for that. Their expertise is just second to none, so we're really proud of them. And then, of course, you'll see other tried and true resources. Our 800 number, getpink20.com is another resource. But I also want to talk about very quickly, Drew Clausen has joined us and he's going to help answer questions as well. He leads our AEC team, which is architect, engineer, and contractors / consultants. Specifically, they work with you guys to help answer any of the questions that you might need, to provide any lunch and learns that you might be interested in. You're going to see them across the country, active in the local IBAC chapter and the local AIA chapter and all of those things. So we want to make sure that you're familiar with them and you look to them as a resource as well. So without any further ado, I just want to thank you again for your time and take any questions.
Wow, Tiffany, there was a lot of juicy info there. And so we will dive right into questions, because one thing that I was so intrigued by the presentation, I forgot to get the question queue lined up here. Amazon. So we're going to have Kit join us in a second, but just a few points that what I thought was really insightful was and I did take some notes here. So I guess maybe I'll start with the first question is kind of traditional products we see, getting into the, big box stores. I mean, I typically see like the 2 inches and 1 inches. Is there other sizes of rigid insulation that will be able to be more available as we're looking on thickening up our sweaters, or you just see most contractors just doubling it up with 2 inches?
That is actually a really great question. So yes and yes.
Okay.
So we will see a lot of just doubling up if that meets the requirement. Typically in our big box stores, you're going to see a material that is available in a unit size that would get you to the prescriptive code requirement. So I think we all know if we go to the ASHRAE standard, we have the option of using the prescriptive code requirement that just says, for example, you need R20 insulation. So if I'm using XPS, I need 4 inches of insulation. Well, in that particular local market, you might see 2-inch XPS provided. So you could get there with 2 layers. However, we also can manufacture and do manufacture that material in greater thicknesses than what you're seeing in the stores. So please don't feel like you're limited. Please reach out to us. Those are standard sizes as well. They just may be available at a distributor, or it may be like in the case of a Plaza Deck application, a lot of that actually comes straight from our manufacturing plant to the job site because it is so specific to that job site. And usually those job sites are very time sensitive. So we also might be providing it from that perspective as well. But from a manufacturing perspective, we can go up to 4 inches. Then from there, you'll see either additional layers added. You might see some adhesion. That might be an option as well. So a lot of different solutions there.
Awesome. And I see that Louise is joining us. So again, the Canadian contingent of Owens Corning is joining us. And Louise, I need to talk to you because there's some cool products here that I was aware of. I know that I was part of a team that bought all of the last foam glass out of that Portland factory that there's some random materials in Edmonton that we used for a project. So glad to see that is back into production and into the process. And I'm definitely going to be intrigued about some of that. Really like the slab edge details. And again, I really appreciate how, again, when we're looking at installation, that the package you provide is not only just the sweater details, but the slippers and the toque. So you're including all of it. Sorry, a beanie hat to my American friends. I prefer a toque, but that's just the Canadian person. So let's get into the question because there is a good queue here. So Kit, if you're available, if you want to join in, I'll give you about. Perfect. Go ahead.
Thanks. So I've been reading a bit about thermal drift, and if any of you aren't familiar with that term, it's the amount of R value that a material loses over time. And what I've been reading is that foam in particular is more susceptible to thermal drift, but I'm not finding any specific information from manufacturers about how much R value over time their foam products lose, which, I could be, well, anyway, there's probably not a great sales benefit in saying, oh yeah, our EPS loses half its R value in 2 years, right? So, but I would really love to see from manufacturers like Owens Corning that type of information, because when we, for instance, put foam sub slab, that's our only chance to get that right. And if it's R10 today and R5 in 2 years, we've really fallen down on the job here. So I'm just wondering if you can talk about that a bit.
Yeah. That is definitely a challenging question. And I think there's a lot of, I won't say confusion in the market. There's a lot of energy around that. And there are a lot of different numbers that get reported back, which I think does lead to confusion. So I don't know that it's necessarily intentional, but it does create conflict. And so on behalf of the industry, I apologize for that. But I will say in some ways it depends what conversation we're having between the United States and between Canada. As you know, that the reporting requirements are a little bit different between the Federal Trade Commission and what's required up in Canada. However, that is something that we really do work towards to make sure we're compliant in both, as well as we also like to report our values at different temperatures, because if you remember the Building Science Corporation study that documents that thermal performance at different temperatures does vary with all of these, especially plastic insulation. So all of that said, I think maybe an easy kind of clear way to lean on that is, first of all, definitely reach out to all of your manufacturers. We would love the opportunity to provide all of the information that we can in the different formats that are needed for your project and your location. But also there is a study that is honestly a continuation of previous studies. It's over 30 years worth of collected data and sample material. Particularly, they were pulling up EPS and XPS from Alaska installations. They were looking at roadways, but what that does also help us to learn is, again, how this performance of this material lasts over time. So they're pulling up the material, we're looking at moisture content, and we're looking at it as a result of that at R value. But what that is also telling you is what the R value of an insulation that was manufactured 30 years ago and has been put through its paces, what it's still giving you. And so I think you'll be pleasantly surprised to see that information and the number of studies that have been repeated, which we would definitely like to see more and more studies done. But the number of studies that have repeated themselves with those high numbers are how we get to, for instance, with the XPS warranty for the lifetime of the product, that you're going to get 90% of the R value of the material. And just to clarify some potential confusion that might be in the market, starting out with a higher R value, even if you do lose some at the initial manufacture process from the time we pull it off the line to the time that you get it on the wall or get it into the slab, if the R value was still higher to begin with than some of the other materials that were out there that are claiming a different thermal drift, you're still getting that higher R value to begin with, and still throughout the life of the project. So I know that's a little bit confusing. I hate to kind of circle around with that, but we've been more than happy to provide the right information for your particular project, depending on which country you're in.
Great question. And boy, did we get nerdy and deep. And I mean, we typically do talk about component spotlights getting geeky, and we definitely went there. So thanks, Kit, for that. I believe, Michael, you're next. Michael's question was, can we just address issues of embodied carbon in the fiberglass versus the rock wool? So maybe we'll go a little lighter on a higher level conversation on that. Tiffany.
I will say that I'm probably not the best person to answer that as our entire sustainability team is. Currently, we are embarking on a project right now to look at embodied carbon with multiple products throughout Owens Corning. I don't know, Drew, if you have any other things to add related to that right now, but it is something we are currently working on documentation for.
And before maybe Drew pops in there, do you guys have EPDs coming out or have them for your current products?
We already do have them, yes.
So that helps kind of at least give people information to where to go. And
yeah, Yeah, definitely. Yeah, EPDs are kind of a given and a standard for us. And then the new product, that's already something that's in the works for us. But this embodied carbon is a big project for us to look at because, again, it kind of depends a little bit on location as far as where the product is made, where it's going, and those types of applications. I don't know, Drew, if you have anything to add there.
We do have EPDs available, and I think they're listed on UL Spot and some other online databases that are available, and some are plant specific and some are kind of network specific as well.
Thanks for that, Drew. And again, I mean, embodied carbon, I mean, I think to the passivos community is kind of part of our regular discussions, but it's still relatively new in the marketplace to a lot of different builders and part of the construction industry. So the fact that you guys are that far ahead with very specific EPDs, I don't know too many manufacturers that actually talk about per location, per manufacturing facility. So that's really insightful. Thanks, Michael. Moving over to Sarah. Sarah has a couple questions, so we have time for both, Sarah. So over to you.
Okay, great. Can you hear me?
Yeah, hi, Sarah.
Hi. So I really appreciate what you were saying in the beginning about how this is a process and you don't see it as checking off boxes and, it's a kind of a longer journey that we're all on. So to that end, are you looking at any carbon sequestering insulation types? And along with that, do you think you could reach 100% recycled content on your plastic products? I am not sure, just to be upfront, that plastic products really fit into a carbon neutral future. So maybe you could kind of comment on that long-term vision. Hopefully short, but long-term.
Yeah. Okay. Yeah, that's definitely a conversation that we have repeatedly here at Owens Corning. We want to make sure that, again, we're making products that have a good future, not only in just the performance of the material itself, but how it impacts our environment. And so while I can't speak to carbon sequestering specifically at the moment, I can say that like we just said earlier, we do have EPDs. We are particularly studying carbon, embodied carbon within all of our materials. But additionally, I think the conversation that we have internally with ourselves is what is going to not only provide a product that has a great responsibility, materials from a perspective of embodied carbon and recycled content, but also gets us the performance that we need. So we're looking at the highest R value performance so that we're reducing the energy load requirement within the HVAC system or the operating system of the building itself. So I think as designers, we're always struggling with that, right? And we would love to see a future where we are using materials that don't have that to begin with. We do want to make sure that we are responsible. So this is something that we are, again, going to keep striving for. As an example, the global warming potential. We actually had a very low global warming potential compared to competitors in our previous formula. It wasn't something that we terribly advertised, maybe to our detriment, but when we came out with the new formula, that was something that we identified. And that's why you see the comparison with another leading competitor versus our own, because the reduction was so great. And we're not going to stop there. We're already working on, what's next, what's the best thing that we can do here. As far as recycled content goes, that is a goal for all of our materials, as you can see with our mineral wool, with our fiberglass material, with our cellular glass material, as well as our foam plastics. With our foam plastics, we do have actually one of my good friends also here in Texas, one of our product managers. A huge portion of her responsibility is our recycling program, which we are very proud to have already instigated. So we are taking back material. The logistics are the challenges for us right now, being able to get those materials from either the place that they are created in a plant. So an ideal scenario, like a precaster, we can reclaim that material and recycle it, or from a job site. The other limitation there is that the foam plastic can be reused. So for instance, DFW Airport, where we're located here, that insulation was removed, the waterproofing was replaced, and then they put that insulation back down. So no more insulation needed to be made in that scenario. It was already cut and tapered and intended for that particular roof, and then just put back into place. So there are some challenges with reclaiming something when it could still be in use, but we would definitely love the opportunity, and we are still going to work towards recycling that material. With regard to things like fiberglass and cellular glass insulation, we'd love to recycle more. We need more recycled content to put into those materials. So as opposed to Europe, where we're able to get more recycled content to go into our cellular glass insulation, that's something that we are limited in availability in America. So we need to do better as Americans, and we can definitely step that up. So yes, that is something that is a goal for us, and that's something that I hope that we will achieve in our lifetime. And again, if foam plastics is not for you, or if you don't need those performance properties, we do have other solutions as well.
Man, great information again. I really appreciate the continuous improvement. Sarah, did we answer all your questions? I know you fired a few at Tiffany, and
A lot of the time, yeah.
Yes. Thank you. That was helpful.
yeah, really insightful stuff. Moving along, thanks, Sarah. Jean had a question, and Jean, you want to come on and ask it, or there was just a question more about just discussing the Formula NGX product, and maybe want to just again kind of review that, because it's new to the marketplace given some of the policy and adjustments, but you guys were also leaders in looking at better ways before you're forced to do it. You're already making strides to do it, so maybe just dive into to that product a bit more.
Sure. I'm sorry, I just stole my thunder in the previous answer, but yeah, in 2021 and 2020, we saw, particularly in Canada, those ordinances change where we wanted to make sure that we eliminated the HFC 134A blowing agent, or extremely reduced it. Was actually the requirement, not just for Owens Corning, but for all of the foam plastics that use that material. So this was actually a process that we worked on for over 6 years. Lots of experimentation, and the big ask of our team, our science and technology team, was that we did not want to compromise performance. So what were we gaining if we lost our ability for fire resistance or thermal performance in seeking this reduction in global warming potential in the blowing agent? So that was a big task for them, and we're really proud of them that they achieved that. So it is a one-to-one comparison for us. So if you had a fire system, fire rated, roof assembly before with the standard Formula product, you would also be able to get that with this Formula NGX material. And that's really the difference of the material. From the calculations that we've been able to do based on the impact that would have in our environment, it is like, so swapping out 10 boards of the leading competitor's material versus ours was like taking a car off the road for a year with that NGX material. So that was really the goal and I think the achievement there. And again, we're not stopping there. This is just where we wanted to go. From there, you saw this being picked up not only just in Canada, but also in various states around the country. And we actually have a map online that is updated in real time. It's our www.owenscorning.com/NGX, I believe, is the URL. Hannah can correct me if I'm wrong. But that is where you can actually go and see if your state is one of the states that has already adopted this particular ordinance and language. And if there is any concern about that material being sold in your area, please rest assured that, first of all, the NGX is available anywhere in North America, regardless of whether the state has adopted an ordinance or not. But also for the states that we need to make sure that we sell that material to, we have a lot of stopgaps in place throughout the process to make sure that the right product gets into those locations. So it's something that we're really proud of, and we're working towards the future where we have all NGX in the US.
Hey, Tiffany, just to talk about that too. So just from a marketing, I know like some other brands, they've kind of eliminated one color and then the new product is a different color. For you though, it's really the same pink stuff. It'll just have the NGX label on it. And that's the real determinator. Just because again, as your again, stores and other products are removing and making that transition, there still might be some product that's out there in a area that is designated as has made the compliance changes, just about getting rid of the old material. Or have you found that in some areas that they've discontinued or taken things off shelf and have kind of, you know, moved things around? Or so again, a couple of questions there, just with where product is in the supply chain.
Yeah, how did that transition happen? So that was a good question that came up as these ordinances were coming online. And this is all kind of a generalization, certainly, you know, verify with your local jurisdiction. But in general, the ordinances basically stated that we could no longer sell a product that had a higher global warming potential or had that blowing agent in it. In those states past a certain date, and those dates, of course, vary as to when those ordinances went into effect. But then after that, they could sell through whatever product was in existence. And then we would obviously not be shipping any more material into that area. So I guess theoretically material could still exist in some of those states. I would think it would be improbable. Especially given the pandemic and how much, you know, supply chain wise, everybody really wanted, you know, product and material. But that is a possibility, of course. Now, as far as the labeling goes, yes, we were very adamant about maintaining the pink color, the iconic patented pink color, if you will. I think that really stands to Owens Corning, our brand. And as we got to start, so rarely do I get to brag on my own company, but we you know, really got to start talking about all of the other qualities and aspirations that Owens Corning has. So the pink really does mean something to us. But you'll see that the letters NGX are all over the face of the board, and the labeling, they're on the side of the board. So when you see that 150, 250, 400, 600, 1000, which, by the way, those are all the compressive strengths. You'll also see the NGX next to that. And then if the product, let's say it arrives on your job site, it's wrapped in a white wrapper, that material will have a green sticker to also identify the labeling. So that was something that we went through specifically with our customers to make sure that they have a very easy, clear way of identifying that they have the correct product and that it's getting to the right place in the right location.
Excellent. Yeah, because a lot of times too, again, when you're bringing in product and if you're having compliancy, you need to make sure that it's as soon as it's delivered, you know before it gets installed, and then you're double checking to say, hey, what was the right product there? So great stuff. Roy's got a question about compressive materials. So Roy, do you want to join us and ask your question?
I was just asking about how much PSI can it take before it deforms, especially for rooftop decks or patio decks?
So specifically, Roy, do you want to hear about XPS or cellular glass insulation?
Oh, there was a slide that you had shared that had a gentleman installing the product. I think it's not the XPS, it was the other alternative.
Okay, the cellular glass. So I'll just answer both. That'll make it pretty easy. So commonly XPS is chosen for plaza decks specifically because of its compressive strength. There may be another way you can add a facer or something to another material. You might get higher compressive strength, but typically that is why we've kind of ventured towards the XPS in these different markets and applications for vegetative roofs, split slabs, plaza decks, things like that. And typically what we're using is a 40, 60, or 100 PSI. I like to ballpark kind of start in the 60 PSI range, and then if you can go lighter, you can go lighter and get up to a 40. If you can go heavier because you're going to park a truck on top of it, then it's a 100 PSI. So you've got kind of a good range there. But to be able to calculate that information, there is a document that's available online. We commonly call it the Foundation Properties Bulletin. And basically that is taking the amount of deflection that is considered acceptable, which in the case of XPS, it's 2% deflection over a 20-year period. So if you think about, how much that is, it's practically not noticeable. So over that period of time, that's considered acceptable. And we would see that those numbers are used depending on your loads. You can actually look at the loading, live load versus dead load versus ultimate load versus the yield and determine which one would be applicable for your particular project. So that is one way of looking at that information. We also have AASHTO information, which may not necessarily, be very interesting to some of you guys, but maybe it is for roadway applications. And so they have a slightly different amount of deflection yield requirement. We do have the formula tested for that as well. So you'll see a lot of that used in, for example, in Alaska. I talked about the Alaska study. The reason why that is so important and critical is we are using that material to protect the permafrost. So again, yes, it's a foam plastic product, but versus what would typically be used like a gravel material, you're not getting any thermal performance out of that. So we want to protect that permafrost, which again affects the amount of carbon that's released. So yeah, it's kind of a tricky conversation to have there. So we do have that information. Now, all of that said, that is for XPS. Cellular glass insulation is kind of your next step up. So where XPS leaves off, where we stop at 100 PSI, cellular glass can pick up and go past 240 PSI. Depending on the application that you're looking for. We have different types and grades that are available for that. The R value is a little bit lower because you have to get that density, but where you would have practically no option with regard to having that much compressive strength requirement, this is where that material can pick up. And that material does not yield. So it will eventually shatter when we do cause failure. So we don't see deflection at all. So if you are building, let's say you're building a terrazzo floor in an airport scenario where they need to drive trucks on top of that beautiful terrazzo, you can't have deflection. It's just not an option. This would be a great solution for that. So we have a solution for one or the other, just depending on what your needs are, I guess is kind of the answer there.
It's the top of the hour, and we will let some of our guests go. However, we know that you're going to stick around for a few extra minutes because there are more questions. So we will switch gears from the main component spotlight to the last, what we're calling nowadays, the final 15, where we'll hopefully fire through the last bit of questions so we can get carried on with our day. Thanks again to everyone at Owens Corning for putting on this effort and making sure that Tiffany had all the backup she needed. And as you can tell, she didn't need much. She was on point today. So Tiffany, thanks for that. Drew and the rest of the team, we appreciate it. If you do need to go, again, you saw at the top of the hour all the events that Kim highlighted. Again, the podcast, the new magazine, and all the upcoming Passive House Accelerator live event. So if you missed the beginning, again, check the accelerator, and there you go. There's all the list of the upcoming events. So check it out, and we are going to continue on with questions. But if you do need to leave, again, take care, safe travels, and we'll see you soon. And continuing on with the questions, we had Jean that had another question, and I'll just ask it. It says, what are the solutions for shear strength when using XPS as sheathing?
So the standard that you're going to look for there is the AC71, and that is an actual test. It's a conglomeration of testing that addresses XPS being used as a sheathing. So we actually use that in addition to air and water leakage testing as well. So you'll see both our air and water leakage testing as well as sheathing requirements. That said, I think just kind of the quick down and dirty answer is that you're going to need to provide lateral reinforcement within your structure. So, if you're doing steel stud and you see the holes between the studs, and that's actually for lateral reinforcement, not just to run your plumbing and your electrical. So you would need to provide that lateral reinforcement. if you're using XPS instead of a chipboard sheathing, for example, but that is something that we do see, and we would definitely support and encourage as a way of not only providing good continuous insulation, but maybe to help reduce additional materials within the wall, get things to go up faster and with less impact.
Excellent. The next one was Joshua. I think Josh has to leave. Josh, if you're still here, you go for it. Otherwise, 5, 4, 3, 2, 1. He was just had a question again. R values for materials below grade, especially since talking to pH certifiers in Europe about foam insulation below grade, if it's exposed to water, can cause a drop in overall performance. Can you comment on this? And yeah, he was saying, I guess XPS is an R value of 5 point something, and then below grade it's measured at 3.9. Can you comment on that?
Yes. So a couple of comments on that. Number one, something that I learned as we purchased Pittsburgh Corning and began to look at bringing Pittsburgh Corning insulation solutions from Europe over to the United States. It's not like foam glass left the US, but I would say that there was a lot more pipe foam glass in the US than there was building insulation for a long time. So as we start bringing some of the solutions back, like the Paransol application, for example, or like some of the roofing, one of the things that we learned is that measuring R value is different over there than it is here. So again, I think I probably alluded to the Federal Trade Commission requires us to report R value at 75 degrees mean temperature, which is a beautiful day. I don't know about you. It's when we probably don't need as much insulation. And then things start to fluctuate as we get hotter or colder. And that's something that we've studied, that other organizations like the Building Science group have studied, where we've looked at, maybe the blowing agent begins to condense around 40 degrees and you're starting to lose R value, whereas that was one of the highest R value products that you could put in before that. So I would say take that with a grain of salt, number one, because they don't necessarily translate over directly. Number two, I did allude a little bit earlier to the Alaska study, which I invite you to look at. The University of Alaska put on that study, and it's, again, pulled up insulation that was buried below grade in these applications for years at a time. Some of them have reached, I believe, close to a 30-year period. And there's encouragement to continue on doing that. We would absolutely support that as we have in the past. And so they are looking at pulling up from different sites, both EPS and XPS. And when they pull that insulation up, they measure moisture content. And as a result of that, they measure the R value of the material. So 2 reasons why the moisture content matters. Number one, when it has water present, obviously there's your R value because water is conductive, right? So we would expect anything that has a higher moisture content, even if it claimed to drain, doesn't necessarily provide a higher R value. In addition to that, when it's full of water and that water freezes, you start to cause structural damage to the insulation itself. So in between all of that cellular structure, that also creates issues as well. And then ultimately, even if that water drains out later, you would still have damage to the structure, not able to capture the gas as well as it once did, and so you would lose R value. So we saw consistently over time that those samples that had higher moisture content had lower R value, and predominantly it was the EPS that was demonstrating lower R value. Now, kind of a similar conversation to have there versus what you're citing in Europe. The resulting information that was kind of new to this study that was recently done with Alaska was that they suggested a lot of different factors that could be applied to the R value of the insulation. So for example, if you were looking at the data from one perspective, maybe you would need 1.5 times the insulation to meet the requirement that you sought, for example. So there were multiple multipliers. I don't mean that as a joke, but they were suggested within that study It's a very short, sweet study, super easy to look through and peruse. We have links to that on our website. Hannah might be able to link that as well. But you can also get that at the University of Alaska's website. A lot of in-depth study into the longevity of this material and how it's going to perform over a long period of time, which is something to be proud of again with the foam plastic, if it's going to be around for a while.
Yeah, no, very insightful, because again, we have these discussions of just, hey, most builders build a 2, 5, 10 type warranty, but that ideally we are looking at not just 100+ year systems, but 200+ years. And so what potentially is the product lifestyle, or when it's sandwiched in a wall, and can we not have to worry about it, that again, our grandchildren and their grandchildren will be able to enjoy the comforts of the sweater products that you guys provide. So excellent. So Larita is not with us anymore, but her question was, which mineral wool product offers 1 hour and 2 hour fire ratings to meet UL standards W605 and W606?
Oh, my head is 605 and 606. But with regard to hourly rated walls, you're able to achieve that with both our batt insulation and our rain barrier exterior continuous insulation. So either those or both are part of rated wall assemblies. And we'd be happy to help you look that up on for your particular application.
The question was, is there a finish to the spray foam urethane foam insulation by Owens Corning to be used as an exterior finish product? Huh. I haven't heard of that one. That's interesting.
Yeah, so we have both interior and exterior grade spray polyurethane foam insulation with natural polymers. Certainly, it's still a product that I am learning about, and I know a lot of other people are as well. So we can definitely follow up with more information. But what you're mentioning is generally accepted as the 2-pound or the closed cell spray polyurethane foam insulation, which those are typically less vapor permeable. They are also moisture resistant, and in some cases can be classified as an air and water barrier system. So it would be that type of material. So yes, that is a possibility, and we can definitely follow up with more information related to that.
Yeah, it's always interesting, again, because typically we want to have rain screens between that continuous insulation layer and then the cladding. And I know some products where perm ratings maybe not as critical, having a stucco finish, could be applied. But again, it just kind of gets tricky when you're connecting different products, especially if it's not something you guys carry. So,
yeah. Or you're creating a perfect wall, right? Everybody knows about the perfect wall where the vapor barrier and all the insulation is outboard. That's also an option. So, yeah.
Sam, you'll have the last question. Sam, if you're still with us.
Yeah, I'm here.
Go ahead. Yep, we hear you.
So I have a lot of pink fiberglass that I want to replace and upgrade. So, and you were saying that you guys have recycling stream. How would I get my stuff to you guys so that it can be reused?
That is not a common question I get, but let's have you reach out to gettech@owenscorning.com, and we can go from there on what we can do to work with you on that.
Okay. All right. Thank you very much.
Sam, no, that's a great question, because here in Vancouver, we have a company called Unbuilders that is unbuilding homes and being able to put all of the materials that are in that, older home into the recycling and waste stream. And so having these kind of back loop chambers, and, unfortunately, sometimes that material coming back to the manufacturer is not as clean as they would prefer. So it's a question of how to, be able to take back their material, just kind of like the whole pop bottle and can situation. So it's definitely something that I think all manufacturers are doing. And kind of to kick off, to wrap things up, the way how you started at the top of the hour was, Owens Corning is doing a lot to be an innovative and inspiring company because you guys are, a national and global company. And so really great to see the strides you're doing for creating the culture that you're working on. Well, Tiffany, we are going to wrap things up because you did an excellent job providing some information. And I know personally, I got to call my local rep and check to our local distributors to see what some of those products that are provided. I definitely know that the mineral wool is big, especially with COVID. There's a lot of issues in the mineral oil supply chain. And it was great that you guys were able to help out with providing the products you do. So I hope everyone will do a bit of homework and find your local rep and inquire about some of these products and see how you can include it in your upcoming projects. And again, Tiffany, thank you very much. Kim, is there any parting words that I missed?
No, just a big thank you to the whole Owens Corning team. You've been great to work with, and we appreciate your support of the accelerator. So thank you.